If you've ever thought about the process of building versus buying a portable power bank system, this might be a video for you. I'm taking all the components you see on the table in front of you and building it into a DIY portable power bank system. Watch this video if you want to see how I'm doing it. The year was 2022, and I thought it would be a good idea to buy a whole bunch of materials and build a portable power bank system. Little did I know that I'd be taking roughly a 2-year hiatus from filming and doing video because of just how busy life got after that second kid. So most of the materials you see in front of me was purchased, stored on my shelves, and started collecting dust. I knew it wasn't going to go to waste. I was going to utilize this in some form or fashion down the road, and it actually turns out that I want to start carrying a 12-volt fridge with me in my daily driver Honda CR-V so that I can start packing my lunches in it. Now, at the time of buying this stuff, I did get a killer deal on the SOK lithium-ion 100 amp hour batteries, so I ended up purchasing 2 of them with the intent of only using one to build the system and the other for an application I'd have down the road. But that brings us to our current day. I feel like I need a little bit more battery capacity in my Tundra, so what I'm actually going to be doing is revamping my original idea of building the battery system off of that battery, taking the Battleborn battery out of my Tundra, and then wiring up the 2 SOK batteries that I have into the Tundra, giving me a lot more capacity in my primary adventure rig. I'll link everything that's still relevant to an Amazon shopping cart below, and if you end up finding it useful, great. On the table here, we'll just talk about what I have going on, and the reason it's so chaotic is because I always want to make sure I'm testing my thought process on how I'm wiring things up prior to spending the time wiring it up. Basically, I have my 100 amp hour battery. It's going to be fed by a 20 amp DC to DC Renogy charge controller running from the starting battery of the CR-V through an Anderson plug in the side of the box and building it into the DC charger, through the negative shunt right here to monitor all the loads coming in and coming out, and then charging the battery. That's going to be the primary way I plan on charging this system. Secondarily, if I'm ever at shore power, I'm home or whatever it is, I'm going to be plugging it in using this 120 volt 5 amp charger that'll be inside the system as well. So it'll be able to be charged off of AC power and DC power. I also want it to be able to accept a solar panel of some sort. So I've got this Renogy solar panel controller. So basically this is going to have 3 different inputs of power. Everything in this system is going to run through, all of the negatives are going to run through this Victron Bluetooth compatible shunt, basically, so that you can monitor all of the loads coming into it and monitor all the loads discharging away from the battery. Everything has to run through it to be able to monitor that properly. We can hook it up right now. Right now, everything is actively putting out power. So I'm gonna have everything going through 2 buses, a positive and a negative bus, and then being distributed out where it needs to. I am primarily building this to charge with DC. I wanna be 12 volt as much as possible. Fridges are 12 volt, battery chargers are 12 volt, all of my electronics can run on 12 volt, right? 12 volt's just way more efficient, and my plan is to run everything off 12 volt as much as I can. In the need of needing a standard outlet, I am gonna run this Bestech 500 watt pure sine wave inverter as an option for 120 volt power, and that'll be going through the side of, I don't even know if they make these anymore, but this is a dual T-stack, 4-man's version of the Milwaukee packouts. Everything's going to be circuit protected in and out of the thing. These are just basically an actual physical circuit you can break, which I wanted to have to keep it safe and keep it controlled when I'm not utilizing it. My 120 volt inverter here, I'm gonna have a shut off, a hard shut off on and off with this guy. The thing about inverters is they just have a constant load to them, and I wanna be able to kill that constant load without having to open up and physically turn on and off the switch to the inverter on the inside of this box. I'm gonna have this mounted to the outside in a location that makes sense so that I can. So that's one of the outputs that are gonna be going from the buses, able to be feeding power. From there, I'll also have just a little Blue Sea style fuse panel to feed things like socket style chargers, USB chargers. And that's pretty much it as far as what's gonna be, you know, popping out the side of this. I'm not doing anything like this. It's really just kind of playing around with the orientation of where everything makes sense and where it's gonna go. I'm gonna shave and clearance all of this, and I'm gonna put in something like this just a mounting plate on the inside of there so that I can mount things to it cleanly. AC charger and the Renogy guy are gonna go down below here, and then everything else is gonna be wired up here and then loomed safely and securely, and it should work out pretty well. One thing I thought that was really cool about this is that it has this little bin up here, and I'm gonna use this to pass through power from underneath for some things that I want to have charging, but also be a little bit contained from like flying out and flying all around. AAA and AA battery charger. I'm gonna cut this out and mount that in there for, you know, flashlights and headlamps and all that I have. All my power is gonna come through right here. So all the inlet power is gonna come through right here. My fans are gonna be mounted here and here, same place on either end. My outlet, USB, and other stuff is gonna just kind of run on 2 rows up either side of this rib here. Should work out pretty well. Funny enough, when I posted that last live video, one of my viewers commented about the Battleborn issues that I was not aware of. And I guess Battleborn has come under fire recently with, oh, I can't remember the guy's name, but Will Prost or Prozest, I don't remember his name, but I follow a lot of his solar advice and his DC 12 volt system advice, and he's been tearing into these things and seeing that there's something seriously not right in some of them, and they're melting down. I haven't had a problem with this one, but I did have a problem with my first one I had, and they warrantied it. This was probably 4 years ago, something like that. Can't really recall exactly what the parameters of, you know, what was going wrong with it at the time were, but it basically wasn't accepting a charge properly. And they did warranty it, sent me out this new one, and it's been sitting in the truck. It's kind of going back and forth whether I even want to utilize this thing. And I'm deciding to push forward because I don't want to put it back in the truck, and I've invested, you know, $800+ in this, thinking it was a super high quality battery, and I don't really know what to do with it. So I'm going to run it in the system. Hopefully something doesn't happen. Hopefully they do the right thing if there is something truthfully wrong with these batteries and the design of them. That aside, I'm just starting to work backwards from what I know, where I know things are going to go, because everything's got to fit in here. There's only so many places certain things can fit. Yeah, so I know the battery, for the most part, the battery is going to go here. I've laid it on its side, I've put it in different configurations, and this is what I think really makes the most sense. DC charger is going to go here, the inverter is probably going to go there, or the 120 volt standard wall outlet charger is going to go down there. I'm going to strap this battery down using some anchors on the inside of everything. I'm going to have these computer fans wired through the side. This one will be semi-covered by the battery, but it's going to be pretty high, so about half of the fan will be above, you know, the level of the battery and not choked out. And then the other one, kind of the same position on this side. That's actually kind of where I'm going to start, is putting these little louvers on the outside, because I know where that's going to go. All of my 12 volt connectors and USB plugs and everything are going to run down this inside rib and pretty much be placed on the outside here, both down this way and down there. And then my inlet plugs for my Anderson plug and my inlet 120 plug, what was the third one? Oh, the pigtail solar panel plug are going to go kind of in this area back there. I've spent too much time analyzing everything, and it's time to just start putting it to use and getting it done. Fingers crossed the Battleborn battery doesn't melt down. That's everything on the inside. The outside, those are all my power outputs. Now I have to have my power inputs. I'm going to put along this back rib right here. Sunoco input for the 120 volt charger. This pigtail for eventual solar. And then the Anderson plug. Another night working away at this project. So I've got pretty much everything in there. No, I don't. But I've got a lot of it in there. Still a lot to figure out. Haven't really started running wires, but I've got a lot of things placed. I think I'll move my negative bus down a little bit so it recesses right here a little cleaner. I need to send another strap eventually around this way so this battery is totally stationary in there and it can't move. It already can't move this way, but it can slide this way. Not much though. So really I want to get this thing going so that I can start using it as quick as possible. Might as well work on getting 120 volt all wired up correctly. Got a lot of this preliminarily wired up. Still need to wire up the inverter to the battery and the DC to DC charger to the battery. Here I am starting the process of running the 8-gauge wire through a wiring loom protector and then basically connecting it under the hood to the primary starting battery of the vehicle and fusing that with, I believe, a 30 amp fuse right after the battery connection so that, you know, you're mitigating the risk of any burning down of your vehicle. Just popped off all the plastics leading up to there and fed it all underneath, popped it through the firewall, little grommet, and bada bing, bada boom. All right, I have the DIY portable power bank pretty much dialed into a usable state. I have a couple last wiring additions that I want to do. We could talk about here in a minute. But for the most part, it is wired up and able to be operational for its intended purpose in this application, which is to serve as the power bank for my Honda CR-V and the ARB 50-quart fridge I have right here so that I can do cooking when I'm out on the road working. That's its primary application. Secondarily, I will now be able to pull it out, utilize it in any sort of, you know, modular platform, whether I'm throwing it in the Sequoia for a day trip or something like that and transferring some of this stuff over to that vehicle, or my wife's Grand Highlander if we're going to like a soccer game or something like that for the kids, to be able to throw a fridge in there and still power it when the vehicle is off is kind of why I built the system. I've been using the system like this for about 2 weeks now. I'm pulled over for a quick lunch stop today, and I figured it would be a good opportunity to do a quick tour and show you guys how it all turned out. If I'm taking this thing out, where normally it's going to be strapped down in here so it's not flying around, but if I'm taking this thing out, reach in the back, and I pop off the Anderson plug, and let's just take that out. I take this out like this, throw it up on the table. Now I did unplug the fridge, but the nice thing about these fridge cords is that they're usually pretty dang long. So if I undo that and come over and plug it in right there, and the fridge powers back up. Again, this is built on the DeWalt T-Stack. I'm not sure if this is still available as a box, but really, it doesn't really matter. You just find a box that works for the best application to fit as much stuff as you need to put in it. Let's take a look at the back, which is where I put my power inputs. Right here is my Anderson plug. This is the input for the Anderson plug that I have hooked up to the CR-V that's circuit protected and run underneath all the plastics of the interior of the cabin to the front battery. This is a NOCO pass-through plug that you hook up a standard 120 outlet extension cord 3-prong into, and it passes power through this to the interior 120 volt compatible lithium ion battery charger on the inside of the unit. And that's all basically used for when I'm at shore power and I want to keep the unit plugged in charged, or maybe I'm in a vehicle that has a standard 120 outlet in the back. It's kind of my redundancy when I'm not in one of my vehicles that has the DC plug wired up to it. And up here, this is currently not wired up to anything on the inside, but there for later use. My intention was to wire up a solar charge controller on the inside of this, which I did have, but the Renogy one that I had just wasn't going to fit. And I know they make smaller profile ones, so if I decide to add that at a later date, I just want to make sure I installed the plug that I bought for that intended purpose there. So on the outside here, this is my outputs for all of the power. So I've got a couple of different 12-volt plugs, this one and this one. This is a Blue Sea, and this one is another one that I'll link down below. I had some cheaper plugs in here prior, and they weren't holding on to your 12-volt plug strong enough, so it was popping out. Even the Blue Sea doesn't have a super strong grip on it. Actually, you know what? The Blue Sea is okay. For sure, it's better than the one I had in there. I wanted something that was obviously going to be able to hold on to these 12-volt plugs and allow them to stay in there. I think, to be honest, I think metal. This one is probably what I'll do with most of my systems going forward. I just don't know if these ones, I don't know if there's a way to adjust the tensioning on some of these 12-volt socket plugs that they sell. The cheaper ones that I bought just don't hold on to things well. So has a pretty good connection. I think I'm going to go with these metal style in the future, a marine grade metal style in the future for all of my 12-volt sockets. Above and beyond that, you have these USB-C fast charging plugs, 5 volt for 4.8 amp output, and this little voltmeter here to tell you how many volts the battery's sitting at. Right here, I have my output of standard 120 volts. So this is plugged into an inverter, which we'll take a look at on the inside. And it's basically there as, not a redundancy, but as needed if I do need 120 volt, although I'm designing most of my systems to run on 12 volt just because it's more efficient. Having the 120 is nice in a pinch if you have something that just won't run off of 12 volt that you need to utilize when you're out. And right here is my outlet fan for airflow. And over here is my inlet fan for airflow. And one standard I use when I'm doing any sort of 12-volt electrical in a vehicle, or in this case, a battery system, is I want the ability to basically turn off all the little lights and blinking indicators and all that kind of stuff if I so choose, so that it's not keeping you awake, you know, with some annoying glow of a light that you just can't turn off and you have to throw a blanket over or something. So this guy, if you hold it in, will actually turn off, which is nice. Everything else I kept with non-illuminated plugs, so that just is what it is. Now we're going to dive to the inside. Right up front here is my Battleborn 100 amp hour lithium ion battery. Like I said before, I'm just running this thing, even though there's some stuff in the market kind of concerned about these melting down. I don't have a choice but to run it. I don't have endless money, so I got to run what I got, and I invested the money in this Battleborn, so I'm going to run it. This is the heart of the whole system, but really the heart doesn't work without its distribution. So all of my primary wiring is 8 gauge. So I ran a wire from the front of the car to the back of the vehicle, 8 gauge. It runs about 10 feet. You really want to make sure that you're gauging your wire appropriately for the size of the run so that it's safe, and also you're not getting a lot of power loss drop down in that length of wire. It's very, very important you use the proper thickness wire, so check that out on one of the online guides that are out there. I'll try to link one down below. The Anderson plug comes into here. 8 gauge wire runs from the internal to your DC to DC charger on the underside of this. This is your output plugs that run to the circuits of everything, and your inputs are down buried underneath. From there, the power goes out of the Renogy 20 amp DC to DC into a fuse protector. I went with a 25 amp fuse protector, but your mileage may vary. And then it goes into a bus here to be distributed to where other places need power. Now, to monitor the system properly with the Victron Bluetooth app, it has to run through their negative power shunt. Everything coming into the system, its negative has to run through that shunt, and everything going out of the system, its negative has to pass through that shunt in some way, shape, or form so that you can monitor input and output loads. So that's why I ended up using these bus bars, because I just didn't want a whole bunch of stuff having to be run just to the terminals on that shunt. I wanted to be able to pass one main negative cable to the shunt and then everything else going through this, because it's got a whole bunch of different connection points on it. Now down here, you're not going to be able to see it very well, but there's a hidden 120 volt lithium battery charger that I use for shore power. So it's buried all the way down there because that's where it made most sense to fit it. So that's really all the major power inputs, and the power outputs are, you know, what you really built the system for. So all the 12 volt power outputs come off the battery directly, go up to my fuse panel here where they're all individually fused so that I can tell what's what. And then they run down here to this amazing loom I made, right? And then they run down this and they exit out the front for whatever I'm using them for. Another thing to take note here is this guy is my temperature sensor for the 2 fans on the outside, and it does work at a certain temperature, 27 degrees Celsius. I forget how many, I think it's like 75 or whatever, somewhere around there degrees that it turns on. And I have actually heard it turning on and off occasionally, mostly when I was using my 120 volt charger in the garage. But the other day when I was running a big load, I had a big drawdown on this, and we were at like 40% on the battery. When the DC to DC charger was throwing the full 20 amps or 19 point whatever amps into it, it did kick on the fans in the back of the vehicle. So that was interesting and good to see that it was operating. It was kicking them on and kicking them off. So the fans are working to cool down the system if it gets too hot. And this, you can just dial up exactly what temperature you want it to come on and off at. Now, I had those acrylic PVC sheets that I was debating on using in this for the backing plates for here and here, but I just decided to go with a scrap piece of 1/4 inch that I had laying in the garage because it just made it easier to connect things to. It doesn't look quite as pretty, but I don't really care. So it works. It's very functional. Last and least is the 120 volt pure sine wave inverter I have right here. It's a real low quality one. I think it's Bestech. So is it really pure sine wave? I don't know. Probably good enough for what I need it for. If you're ever using a system like this and you need to make a tight turn, just know you can buy little plug adapters to make a right angle turn immediately. I wasn't going to be able to do that with this plug directly into that. So that worked out pretty well. And then I haven't hooked it up yet, but I have a solid on off and then disabled power cutting knob I'm going to actually install in line to the power input for this, and then plug it in up here, have it recessed in up here so that I can turn this unit on and off without having to open up the top of this box. Now, I haven't had the time to do what I want to do up here yet, but basically up here is going to be a charging station for camera batteries, regular standard flashlight batteries, and that's really it. It's just really going to be a kind of modular battery area up here for all of my external battery systems that I might need to take away and utilize when I'm around camp or what have you. The one thing I haven't figured out is the DC-DC charger has to have a ignition on switch that goes to it that activates its transfer of power from its input power source to its output power source. Hooking that up to the positive side of the lithium ion battery doesn't do it because it's matching the same voltage as the battery's putting out, is what I'm assuming in kind of the research I've done. So that's not allowing it to initiate that transfer. But then when I hook it up to the outside source, the input power, which is basically the power coming off of the starting battery of my Honda or whatever vehicle it would be plugged into, it fires up and reads and starts initiating that charge. But I'm not sure if I'm just not finding how to set it, but the Renogy 20 amp DC to DC charger doesn't seem to have like a minimum voltage cutoff to it. So it did draw down my battery in this thing over a couple of days and kill the starter battery where I couldn't start my vehicle. So any period where I'm not running the vehicle for any amount of time, basically over the weekends when I'm not driving it for work, I'm going to flip the circuit breaker underneath the hood and kill any of the power going to this thing because I haven't found a way to be able to kill it outside of doing that. It just kind of has a parasitic draw on the system. Comment down below if you have more insights into that than I do. I could honestly run a length of cable to an ignition on inside of the vehicle, but I don't really want to do that because I don't want an additional plug to have to worry about. I kind of just want the singular Anderson plug to worry about. I don't want to have some random additional wire running. And then in a pinch, I carry the Noco battery jump boxes in all my vehicles anyway, so I think I'll be able to manage it the way I'm doing it, but maybe long term I might put some sort of battery cutoff on the inside of the vehicle so I don't have to pop the hood every time I want to cut power to the system. There you have it. Not really a DIY how-to tutorial, just some general knowledge and maybe some takeaways you might have from my process of going through and building this DIY battery bank. If I was to do it again in the future, I don't know that there's anything else I would do differently. I'm pretty happy with how it's turned out. It's very usable, very functional. Hopefully this gave you some good information. I haven't built a 12 volt system since I built it in my truck a few years ago, and I just wanted to refresh some of my knowledge of 12 volt and the exercise of working with 12 volt because obviously I'm going to be building a system for the Sequoia coming up. Even though I could utilize this system in the Sequoia or maybe a pre-built portable power bank system in the Sequoia, I'm kind of torn between doing that or doing a permanent install in the actual vehicle like I have in the Tundra. So I'm just kind of playing around with ideas. So there's a good chance I'm going to be building another permanent system in the Sequoia itself. And I'm glad to have the updated, reference of doing it in this box to help me when the time comes. So I can make that look really, really clean and operate really, really smoothly. Throw any comments or questions you might have down in the section below. Follow the link below to join the email list. I'm going to be launching something here at the end of the month, so be ready for that. Other than that, I appreciate you guys watching the video. Have a good day.